Welcome to Chapter 3, the Relational Model 2, SQL or SQL. This is CIS 307 and this is Nancy Dugan. The chapter itself begins in your text on page 71. You should have read the chapter before reviewing the lecture. You are responsible for everything in the chapter as well as everything in the lecture. The chapter begins by giving you some introduction to SQL itself. SQL stands for Structured Query Language. It was originally developed in the mid-70s as SEQUEL and later abbreviated to SQL. You will often hear people refer to it as SQL or refer to it as SQL. The word never spelled out as the word sequel, but verbally to say SQL or to say SQL. Either one of those is an acceptable way to refer to it, and I'll go back and forth as many people do. The basis of SQL is in relational algebra, which we covered at the end of chapter 2. In order to do the exercises in this chapter, we will be using a piece of software called MySQL or MySQL. You'll be able to download this software. There should be no cost to this software at all. I found my copy at Oracle. I did have to create an account in order to download the software. It did force me to do that. Make sure when you create that account you do use your .edu email address. That edu email address is very powerful in the software world, allowing you to get access to things that you cannot get with any other type of email address. I tried to do screen captures, etc., but had a lot of problems doing that. It did take me the better part. It took me a couple of hours in order to get this account created, get it downloaded, and get this software installed. That's why this week as I work out the 3 hours of class time, I did allow in for one of those to be your downloading of this software, and that's why this is a lighter week. One student did tell me it forced them to give a company name and title. I would recommend then that you use the title of student and the company name of Eastern Iowa Community Colleges if it asks you for this. For your knowledge, before teaching this class, I had never used this tool. My experience is in SQL Management Studio, which is a Microsoft product. That is a very expensive tool. We were not about to make everybody purchase it, so it was recommended by the department coordinator when asked to teach this class that I use MySQL. Again, I did download it at no cost, so you should be able to do that. The software itself, when you open it, I downloaded the Enterprise Edition. Not 100% sure if I needed that much or not. I so far have only been using this MySQL Workbench, and the first step you're going to need to do, of course, is download the SQL exercise files from the doc sharing area of your course. After you've done that and installed them on your hard drive, just place them somewhere where you will remember where they are. You're going to need to connect to them. So you're going to go to the Database menu and choose Manage Connections. Then you're going to go to your System Profile, and you want to click the 3 little dots and select, for the chapter exercises, the Premier.SQL database. I've then always clicked the Test Connection button. So far, every time I've done it, it's simply come back and told me the connection parameters are correct, but I figure if there's a test connection button, then there must be a reason to test the connection. So I push it every time. Click OK and close that window. Then go ahead and go to the Database menu again, this time clicking Connect to Database. Seems like I've already done this, but if I don't do this, for me, it doesn't work. So I have to come in and click OK here, and that opens up my SQL editor. You should see your Premier database here. You may not have some of these other ones where I played around with, but you should see your Premier database. Notice I clicked the arrow to the left of the Premier database in order to expand it. I can go next to Tables, the little arrow, and expand it. I can pick any table and click the little arrow to expand it. Columns, and there's my actual columns. What you'll generally see me do if I were to type them is I'm going to type my commands over here, select. I'm going to double click on the field name, in this case customer name, rather than typing it in. I do that for a couple of reasons. For starters, I noticed that in the text, the author in all of his examples would refer to customer name as one word, but in the examples, they always seem to have it as two words with an underscore. So I want to make sure that I'm getting the exact field name that's in the table I'm using, and that, like I said, is if it's multiple words, is going to vary from the text in the book. The author would have said customer name as one word, and its customer underscore name is the proper name. The other reason that I type them in, or that I double click them rather than typing them, is it guarantees that I'm not going to make a simple typo. If I make a simple typo and I don't realize it, I could spend a lot of time looking at that, trying to figure out why it isn't working for me. You're going to string various queries one after the other. I put a blank line in, as you'll see in a few minutes, between all of mine. So then when you do string multiple ones together, you do have to select the particular query you want to run and click the lightning bolt. And you're going to get this, if you get this type of an error, you can see down here in my output at the bottom how I'm getting an error. That simply is indicating that I haven't selected the table. Or excuse me, that I haven't selected the database. So if I come back here for the first one and simply make sure that Premier is selected before I hit execute, it should work just fine. You can see here I've selected the customer names from the table customer, and seeing my output here, it's telling me 10 records returned. Of course, like most Windows products, you can expand the various panes of the window to whatever size you need to expand them to for the particular task that you're currently working on. To save time with the lecture, I went ahead and have already typed all of the Chapter 3 scripts, so I've got them all together here one after the other. This is similar to what your homework files will look like. And let's go ahead and get back to the chapter itself. The author begins by talking about the SQL commands use for table creation on page 73. The command itself is create table. You're going to have a few bulleted items here you're going to want to be aware of. In most SQL products, your table name cannot exceed 18 characters. The table name must start with a letter. It cannot start with a number or an underscore. Table names can only contain letters, numbers, and underscores. I've never seen a SQL product that would allow a table name to contain spaces, with the exception of Microsoft Access. Microsoft Access does allow spaces in their both field names, table names, query names, etc. But if I was teaching you an Access class, I would emphasize again and again that while the product allows it, it will do nothing but create complications for you in your formulas, in your SQL commands, in a variety of other places. So I would emphasize that even though Access does allow it, it is really not a good idea. It is also my recommendation that if you were to create a table, that you would prefix that table name with TBL. That way all your tables have a common prefix. When you sort them alphabetically, when you're looking for things, you'll find all your tables grouped together. Sometimes you may see me use a different prefix to specify a certain type of table. For example, if I have a table called a lookup table and its only purpose is to look up data in another related in a one-to-many relationship to another table, simply for purposes of a drop-down, for example, might abbreviate that as LKTBL. You can come up with your own set of naming conventions. My experience tells me that A, you want to use naming conventions, and B, a prefix is 100 times better than a suffix. People who try to put a TBL on the end find that they cannot alphabetize them and have the tables grouped together, so they're spending a lot more time scrolling. They usually later regret their decision to use a suffix rather than a prefix. So again, I can't emphasize enough the use of naming conventions, and a prefix is preferable. On page 74, the author goes over 5 different data types. These are just ones that you're going to encounter more than any other. There are other data types available. The author covers 3 different data types that you can use for numeric data that you'll be performing calculations on. And it's important to emphasize that just because a field only contains numbers does not mean that it's numeric. A zip code field, for example, I would set as a character string because I'm never going to do any math on my zip codes. I'm never going to add all my zip codes together or multiply one zip code by another. It's truly text. The fact that it is numeric in this country is irrelevant. Of course, you can get into the whole, well, there's foreign countries that have letters in their zip codes would be another argument. But something like a part number, and it might be 100% numeric. I'm not going to make it one of the numeric data types. I'm going to make it a character string. Because that takes less storage space, and I'm not going to ever do any type of calculation on it. So the 3 numeric types that the author discusses on page 74, first is integer. Integer is probably your most common for whole numbers. It can store any number between a negative 2,147,483,648 and a positive 2,147,483,647. And like I said, it can be used in calculations. Small integer, you notice it can store much smaller numbers, just a negative 32,768 to a positive 32,767, but it can be used for calculations. Both integer and small integer store whole numbers. If I need decimal places, I'm going to probably use the decimal data type, with 2 variables in parentheses after, P, in this case P and Q, P indicating the number of digits, Q indicating the number of those digits that would be decimals. For example, if I had decimal parenthesis 6 comma 3, I'm saying that I want a total of 6 digits, 3 of them on the right side of the decimal. Obviously, if I put 3 of them on the right side, then I have 3 of them on the left. So if I said decimal and in parentheses I put 8 comma 2, that's like saying I want up to 6 digits on the left of the decimal and up to 2 digits on the right hand of the decimal. For things that are not going to be used in calculations, your most common is character string. It's abbreviated CHAR, and the variable that you would put in parentheses is the number of characters you are allowing them to store. You do want to be realistic. You don't want to end up with last names of 50 or 100 characters. Generally 15, no more than 20 is more than sufficient. It's easier to add, to increase later. If I originally set it at 25 and then later determined that that was way too big and I made the mistake of knocking it down later to 15, I risk losing the ending characters. I would first have to run a query to determine the length of all of the characters and then figure out what was the max of the length of the characters, and it's just time consuming. If I'd started at 15 and people start complaining that their last names don't fit, so as a result I decide to increase it to 20, that's an easy fix. So again, always start lower and go higher as necessary. A character string can hold alphanumeric, so any letter, any number, any symbol, spaces, anything that the user wants to type in there up to the maximum number of characters that you've allowed. And the 5th most common one the author is talking about is date. And do I really need to explain anything else? I think we all know what dates are. In the first example, starting on page 74, the author is using the create table function to actually create a table. This particular table has 9 fields in it. Notice in my example I've gone ahead and put the prefix TBL on it since we're going to create the table. In parentheses after that, and this could all be strung together, I just put it on 2 lines for ease within the PowerPoint. But in parentheses after that, I have each field name followed by a space followed by the data type, and if appropriate, the number of characters in parentheses. For example, rep num is a character field with 2 characters. So you can see how I have rep num with a space, CHAR, and then in parentheses 2. I list the 9 fields, the closing parenthesis at the end because I had a closing parenthesis at the beginning. FYI, this table does already exist, so there is not a need to create it, but if you want to practice creating it, you can. Just make sure you do not name it rep because the one that came with your data set is named rep. So I named mine just to play with it as TBL rep. This command works just fine. At least initially, you're not going to be responsible for a create table, but you will be in some later examples. Just not this week. Indentation, notice how I used indentation here between just for this line. You'll see me sometimes indent. That's just for my ease of reading. Whether or not you indent, I would never mark off because you didn't indent or something, but remember that indenting various command lines is helpful to you often as you're later trying to interpret, especially very long queries. I have my longest SQL query that I use on a regular basis. If I were to take it and copy and paste it into a standard Word document, is something like 8 pages long for that one query. So we're doing very, very simple ones in this course, but you can get into some very complex ones. So really, you're gonna for the chapter, if you want to do the examples within the chapter, I would recommend that you start with example 2, which starts on page 75. So they want us to list the number, name, and balance of all customers. Now what I've done here is I've gone ahead and taken it exactly how I took it out of the MySQL and pasted it in so you could see it here in the PowerPoint in much larger language, but I'm going to go ahead and come over here. I've zoomed this up, and here's those same 2 lines, and if I execute them, I should get a resulting data set of 10 rows. I have no criteria on here, so there are 10 records in the customer table, so I should see all 10 fields. All 10 records, but I should only see the specific fields that I requested: the customer number, the customer name, and the balance. And sure enough, in my resulting data set here, I see the customer number, the customer name, and the balance. If you choose to work through these exercises on your own, so see on page 75, they give you what it is they want. On the next page, 76, they actually show you the MySQL. They are using an older version of MySQL. I just downloaded the latest version. I didn't even try to find the version to match the text. But then there's screen capture at the top of page 76 where they're showing you the command in a screen capture version. They're using Access. Again, I'm not using Access. We want you to use the MySQL to start to get used to this type of interface. The screen capture then of the resulting data set in figure 3.3a on the bottom of page 76 again is an Access screenshot, but they then on the top of 77 are trying to show you the MySQL screenshot, but of course they're using an older version of MySQL. Ours is much cleaner, so yours should look probably more like mine. Okay. Example 3 begins on page 77. They want us to list the complete part table. Now when you used Access in chapter 2, you would have used the star function, and the star function for all fields does exist in SQL as well. Part is the name of the table. So when I come in here, here's my actual function, and I'm going to go ahead and execute it. Again, I'm saying all fields. I've put no criteria on here, so I should see all records. So there's 10 records in the part table. I've got 6 fields. I should see all of them because I have specified no specific criteria. And example 4 is on page 78. In this example, they want us to list the name of every customer with a $10,000 credit limit. So this is where they're going to start to introduce us to the criteria. So before I would have simply had select customer name from customer. Now I'm adding this where clause. The name of the field itself is credit underscore limit. And notice I said equal 10,000. Notice I do not have a dollar sign. I do not have commas. I just have equal 10000. That's very crucial that with your numeric data that you don't put any formatting into the query itself. So here's the 3 lines you would type, and I'm going to execute, and I get a resulting data set of 3 records that meet this criteria. So they're from the customer table. I'm only getting 1 field and my credit limit. Sometimes beginning users especially like to put the field that they're putting their criteria on in the resulting data set so that they can actually see that, yep, all 3 are 10,000. But you'll find that in many people's opinions too, giving the customer more than they asked for is as bad as giving them less than they asked for. So we only needed to see the customer name. That's all I would expect to be in the resulting data set. That's all that they asked for. That's all that they see. Page 79 is example 5. Very similar to the previous example. Now we want to see the customer name again, but this time of those where the customer is equal to 148. Notice that even though 148 is a number, if I looked at my data types, I would see that the customer number field is a character data type. Text fields have to have single quotes around them when they're in the criteria range. So I can't just say customer num equal 148. I have to say equal quote 148 quote. Of course, I have to have the same number of opening and closing quotation marks, and it is single quotation marks. Here's my query where I've typed it, and when I execute it, I should see simply 1 field in my resulting data set, Al's Appliance and Sport. Example 6, practically the same thing. Now they want us to see the customer name for every customer in the city of Grove. So I could take this query here, copy it down to here, and simply change my criteria row, because you'll notice that the select and the from rows of my query are identical. I'm just changing the criteria row. Notice that I put the criteria in lowercase. You don't have to do that. I did that so that you would realize that the criteria is not case sensitive. Of course, if we looked at the city in the actual data, we would see that it's always capitalized, but I can use lowercase just to save time in my typing when I'm actually typing the query into the MySQL window. The 7th example is, again, pretty simple. We just have a select, a from, and a where. But this time in our where clause, we're actually looking at 2 different fields and comparing those 2 fields using the comparison operators. In your textbook on page 79, the author has given you a list of 6 or 7 different comparison operators: equal, less than, greater, greater, equal, less than, equal, not equal. And then they give you an alternate for not equal that it says is used by some implementations of SQL. That very last one, I've never seen that myself personally. I've only seen the less than and greater than signs with open ends facing each other, which is the one the author says is used by most implementations of SQL. Well, that's the only one I've ever seen, but I'm again only been working in a handful of products. In this case, we want the customer's number, name, credit limit, and balance where the credit limit is greater than the balance. Here it is in the MySQL window. Of course, I've made this larger for you. Yours won't be anywhere near as large, but Here's that query, and when I execute it, I should get 8 rows in my resulting data set. Notice that the credit limit on these 8 rows is always larger than the balance. On page 82, they talk a bit about compound conditions. You used compound conditions in your access queries in Chapter 2. You're basically taking 2 or more simple conditions and using one of 2 operators, the AND or the OR operator. With the AND operator, all of the conditions must be true, and with the OR operator, any one of the conditions must be true in order for the entire condition to be considered true. Their example for on page 82 and 83 is to list the descriptions of all parts that are located in warehouse 3 for which there are more than 20 units on hand. So it has to be in warehouse 3 and there have to be more than 20 units on hand. Select a description, that's all they want to see, from part, that's the table it appears in, where warehouse equal 3, notice the quotes, because if I looked I would see that the warehouse field is a character data type, and on hand greater than 20, again notice no quotes, because if I looked I would see that the on hand field is a numeric data type, one of the 3 numeric data types. Here's the actual command where I've typed it into MySQL. When I execute it, I get a resulting data set of 3. For example 9, if I simply take that same exact query and change the word AND to OR, so even here I could take that, copy and paste it, and simply change. The only difference between these two is the word AND versus the word OR. And I'm going to go from that resulting data set of 3 to a resulting data set of 7. The difference being that in this one, they has to equal warehouse 3 and an on-hand quantity, or an on-hand quantity of greater than 2. So one condition or the other must be met, or both conditions may be met, but at least one of those conditions must be met with the OR. With the AND, both conditions must be met. Example 10 is on pages 84 and 85. In this example, they want us to list the descriptions of all parts that are not in warehouse 3. Well, if I wanted it to be warehouse 3, I would have where warehouse equal 3, but I do not want them in warehouse 3, so I'm going to simply insert the word not in front of warehouse. Here's my example in MySQL. And I'm going to go ahead and execute it, and I get a resulting data set of 7 rows. So these 7 rows are not in warehouse 3. Oops. I selected the wrong query. I apologize. If I execute it, I get a resulting data set of 5 rows. And these 5 rows are not in warehouse 3. Apologize for that. I'm sorry. Example 11, and this is the last example we're going to do this week, because this seems to be a clean break because they start in computed fields starting with chapter 12. So this seems like a good place to break the chapter up. So we're going to go ahead and list the number, name, and balance of all customers with balances greater than or equal to $1,000 and less than or equal to $5,000. That's your customer request. When you actually write the query, I'm going to use the function or the comparison between. Now I could have said where balance greater equal 1,000 and balance less than equal 5,000, I would have gotten the same resulting data set. But by using the between comparison operator, it's cleaner. I only have to reference the field I'm looking at, balance, one time. Between, remember, is inclusive. So that means that if it equals 1,000 or it equals 5,000, it will be included. The between function, again, is the same as saying greater than equal 1,000 and balance less than equal 5,000. It's just cleaner and easier to follow what I did with the between function. Here's the query in MySQL, and if I execute it, I get a resulting data set of 3 records. As I said before, this is a good place to go ahead and break the chapter up into the 2 lecture segments. But now, when you do your assignment, how are you going to get these resulting queries to me? Well, you're going to go ahead and click File, and you're going to go ahead and save your script. I've already saved mine, so I'm going to have to do a save as so I can see the dialog box. And you're going to want to give it a set. Maybe these, I think for the first exercise that you do this week, it's also the Premier Products database that you'll be using. So you might name it Premier Exercises. Yes, it is. You're going to give it a meaningful name, something that you'll remember, and then that SQL file is the one that you will upload. Just as an example, these chapter 3 scripts, if I went to the properties of that file that I saved earlier, only has a 634, well, on disk, of course, a minimum of 4 kilobytes field size. So I'm going to go, that's fairly small. You should be able to upload that. I should then be able to open up your actual script here in my MySQL window and check to make sure that your syntax is correct. I'll be looking for that each query does actually run and gives me the correct data set. You'll be losing points if you did something like spell a field name wrong, or you know, if you're missing a comma, those sorts of things. So you do want to make sure in your assignments that each of your queries does run. Again, when you string multiple queries together like this, you're going to want to select the query that you want before you hit the lightning bolt. So that is the resulting data set that you receive. It will only run the query that you've actually selected or highlighted, but we know it should really be selected. And that concludes our lecture for the first half of Chapter 3. Good luck.